Hi, my name is Marisa Pantoja and I'm going to talk about our project. So the title is Eco-friendly glycerol additive for improved CO2 absorption in aqueous ammonia microconductors. The integrants are Elvis Viteri, Jean-Pierre Lara, and my person. So we have the graphical abstract. As you can see, the visual abstract say that this study evaluates a green solvent system of aqueous ammonia with glycerol for CO2 absorbed capture in microconductors. So the glycerol acts as a vapor suppressing agent, reducing ammonia loss while enhancing absorption efficiency. So the experimental results, as you can see in the conclusions, demonstrate that glycerol concentration of the range of 2 and 3 weight percent improve the overall mass transfer coefficient KGAB by up to 4.8%. Optimist conditions highlight glycerol's potential, as you can see here in this image, as an eco-friendly additive for efficiency of CO2 capture. So the next one we have the introduction, the problem. The problem is that the CO2 emissions from fossil fuels significantly contribute to global warming, although aqueous ammonia is a promising solvent for CO2 capture. Evaporation rate limits its industrial application. So the objective of this study is to investigate the performance of ammonia plus glycerol hybrid solvent in microchannels, analyzing the effect of operating variables on mass transfer and CO2 absorption efficiency. The previous study we have three. So the first one, Kidnebog studies CO2 absorption using ammonia in T-shaped microchannels, finding that the efficiency improved with higher pressure, temperature, and solvent concentration. The next one say that they test hydroxyl-based additives, such as glycerol, to reduce ammonia evaporation and observe enhanced reaction rates. And the last one we have here that they investigate CO2 absorptions with aqueous ammonia in microchannels, achieving up to 96.48% efficiency through optimist conditions. So this work is the first to assess the ammonia glycerol hybrid solvent in T-shaped microconductors, as you can see in the image, proving that the glycerol functions both as ammonia vapor suppressing agent and an enhancer of CO2 absorption. Thank you.
The method is the flowchart of the experimental system of the paper is a different version of part. We are going to detail in the outline of the system. 1. Solvent tank and the ammoniacal glycerol solution. 2. Foam particle. 3. Zeros and air cylinders. 4. Foreigns cylindrical radii. 5. The flow 6. The valvulas. 7. Humidifiers. The frequency, the gas, everything is inside the airport. Number 8. The shaping microbial whitening the thermostat back. 9. Thermometer. 10. Separators, gas, liquid, the same outlet, gas scrubber. What's a gas scrubber? 12. Zeros and sensor and second record the quantified status in the outlet gas. Experimental design. The study is the post-Bacon experimental design while for main the factors ammonia concentration and for anti-WB and glycerol concentration 1 to 3% will be temperature 20 or 14 and the liquid flow rate 3 and 9 and the X the factor was the epileptic and the level resulting in the total 7 17. Experimental including the rotation and the central parts and to the student's statistical ability. And the other political orientation, the shine, the content, and the white content probabilities, and the glycerol, and the and effective harmony and population, and group and series and capture factors. Factors independ in the glycerol temperature and liquid flow and depend variables and the actions growth over the coefficients passing the cost and volumetric molar flux on the action. After experimental models in the first step, absorbing percentage use the white in the different between moles and interactivities divided by the carbon density and divide for 400. In the second case, in the overall volumetric coefficient, the multiplication of the molar flow detail by the pressure in the liquid by the microcanal left for the case 3. The molar flow divided in the different the flow rates and the became model and using the model maintenance, the center variable codic and identity, the following quadrant models are the filtered independence factors are the C and the equation for the absorbing percentage at the coefficient are the coefficient and then the molar flux and the 5 runs in the equations. Thank you.
Well, now we have the graph of the constant UG and the ammonia concentration. Yeah. What is the mass transfer model allowed to estimate the quadratic Bose-Benke model made it possible to predict QGAV absorption percentage, AP, and volumetric molar flux, and AAV as function of ammonia concentration, glycerol concentration, temperature, and liquid flow rate. It quantified both the individual and interaction effect of these factors. Yeah, comparing our theoretical and experimental results. When apply the regression equation to central condition 7% ammonia, 2% glycerol in 30 centigrades, the predicted and experimental value were almost indicate. KGA 205 predict versus 205.08 experimental. We have an error of 0.4%. AP 87 predict 87.8 experiment error 0.3. NA we have 780.7 predict versus 783.2 experiment. Even others operating points division were general 1 to 25%, consistent with the statistical quality of the model. Error 0.95. We were the difference between theoretical and experimental evaluates. Model simplification. And the quadratic response surface does not capture all the micro change hydrodynamic and reaction complexities. Another measure sensitivity QG depend on inlet, outlet, CO2, radius, and flow parameters. Small sensor division, propagate into the calculation. Physical property evaluation. Change is in viscosity, density, and surface tension with ammonia, glycerol, and temperatures modify diffusion and interpartial area. We have conclusions. The study demonstrated that adding glycerol to aqueous ammonia in microconductors not only suppressed ammonia evaporation, but also improved CO2 capture efficiency by increasing the overall mass transfer coefficient, QG. Impact of mass transfer. And in 3 points, filtered liquid films in microchannel reduce diffusion resistance. 2 points. Large interfaces are between gas and liquid engage CO2 absorption. 0.3. Higher turbulence from liquid flow increase the liquid tight mass transfer coefficient. Application and relevation. Power plant and refineries, the hydroelectrics, the ammonium glycerol solvent can be integrated into gas treatment, reducing CO2 emission while emitting ammonium loses 0.2 cement industry, high efficiency, and CO2 absorption up to 91 0.5% capture, made the process attractive for sectors with large oil source emission. Sustainability impact. Using diesel, biodiesel byproducts add value to industrial waste stream and support green, cost-effective carbon capture solution impact. Yes. Features scale up to pilot industry level. Test process in large system to confirm safety. Two, long-term solvent stability. Evaluate during the performance of the ammonium glycerol solvent under continuous operation. Point three, energy and economic analysis. Access, regeneration cost, and sustainability compared to traditional amine base solvent. Thank you.